Hey class, I hope this video all finds you well. Today I'm going to be doing a video for you all to watch in its entirety. We'll be going over what we'll be doing in class tomorrow. So instead of me teaching you the lesson in class and then you having an assignment to do to take home, um, I'm expecting you all to watch this video. It's going to be pretty straightforward and simple. And tomorrow during class we'll work on um, our assessments for you all. And so the topic that we'll be covering today is transformation of quadratics. Like I said, it's pretty straightforward. Should be simple, I hope, for you all. And we'll cover several different things with it. And then at the end, I'll go over the assignments that we'll be doing in class tomorrow. So here's what we'll be looking at during this video. Like I mentioned, transformation of quadratics. So we've discussed before about graphing different functions and what that looks like. As we went over a few weeks ago, this here is called a parabola, and it is the graph of x squared. So if you had f of x equal to x squared, as we've gone over before, this would be what the graph looked like. It's called a parabola. So here you can see it starts here at the origin, and then it works its way up, curving like a U to both sides of the x-axis, working up the y-axis. This lesson that we'll be talking, or the content we'll be talking about today, is talking about how to transform these quadratics and what it looks like to shift and transform them. The first example I want to show y'all is this one here. This is the graph of f of x equal to x squared plus 3. So as you can see here, we still have a parabola here and working up both sides. But as you can see, it doesn't start in the origin this time. It moves up the y-axis 3 points, and that is where it begins. As I mentioned, this is the graph of x squared plus 3. So if you were to have a function like that, x squared plus any constant, you're going to start the parabola on whatever that constant is. So here we have 3. But if we were to have 10, you would start the parabola here and work it up. So all it's affecting, that constant, is where you start your parabola. Here, the next is another example. Once again, we have our parabola. But as you see, it doesn't start in the origin. It starts here at -7 units on the y-axis. So if you were to have this, it would be f of x equals to x squared minus 7. Like I mentioned, if you were to have plus a constant, you're going to move up the y-axis. And here, as you can see, if you were to have it minus a constant, you're moving down the y-axis. So here we're moving down 7 units. If you were to have minus 32, you would move down this y-axis 32 points, and you would start your parabola there and let it work its way up. So here's what it looks like. There's 2 examples for you to see of what it looks like to move up and down the y-axis and transforming those parabolas and how that would look. The next graph that we'll go over is how to move these parabolas from across the x-axis, whichever way that may be. Here you can see one. Once again, our parabola is here, not in the origin though. It's moved over 1 unit to the right. So this would be f of x equal to x minus 1 squared. So you would have that x minus 1, that function, inside of parentheses, and you're squaring that whole thing, and that lets the graph know that you're moving to the right. If you were to have minus a constant in those parentheses, you know that you're moving horizontally, and if it's minus, you're going to move this graph to the right, or transform it to the right. So if you were to have minus 17, you would start this parabola here at 17 units. As you can, it's pretty straightforward, pretty simple. So if you were to have minus a constant in those parentheses, you know that you're going to transform that parabola to the right on the x-axis. You're going to be moving down the right side of the axis or the positive side. This next one we look at here, you can see once again our parabola is here, and it's shifted over 4 units to the left, or negative 4 units to the left on the x-axis. So if you were to see this, it would be f of x equal to x plus 4 squared. Once again, that x plus 4 is in parentheses, grouping that function together. So you can see, you have that function and then you're squaring it, which lets it know that it's a parabola. And when it's plus a constant, you're going to move to the left if you're on the x-axis. So just to be clear, if you were to have x squared plus a constant, you're moving up the y-axis. If you were to have x squared minus a constant, you're moving down. But if you were to have x plus a constant squared, that function squared, you are going to be moving to the right. So it's the opposite. If it's in parentheses, you're going to move it. If it's positive, you're going to move it to the left. If it's negative, you're going to move it to the right. Like I said, pretty straightforward. This is just kind of what the worksheet may look like. Some examples you may see on there, and we'll look at one more. This will kind of be more of what the worksheets, the majority of the assignment that you'll do tomorrow will be like, because I mentioned this is pretty straightforward, but you got to know this base, the base things to be able to progress and do a little more difficult content. So here we'll look at this one. You can see in the red here, once again, we have our parabola here. This time it is not starting at the origin, as you can see. This time we're up the y-axis 5 units, but we're also shifted to the left 5 units. Or 6 units, I'm sorry. So if you were to see this equation, which this will probably be a lot of what you'll see tomorrow on your assignment, you know that, like I said, if you were to have x plus a constant squared, you're going to know that you're shifting that upon the x-axis. So here this is x plus 6 squared. Once again, positive constant in the parentheses, you're moving that graph to the left. So you have x plus 6 squared plus 5. So you move this thing up 5 and over to the left 6 units. Pretty straightforward, I think, and I think most of y'all will, this will be something that y'all can all understand and hopefully comprehend pretty well, and we can move on with this pretty quickly. I'm going to show you one more. Here you can see this one. We have a parabola, but it's in the opposite direction. It's going in the negative direction here. So all this one is x negative x squared. So if you have a negative x squared or a negative constant to any power, that graph is going to be moving in the negative direction. Pretty straightforward. It's the same shape, just in the opposite direction, moving negative. So I hope all y'all understand this, and like I said, tomorrow we'll get into some more details and y'all get some practice with this. So here's a look at the assignments that we will be doing tomorrow. As I mentioned, you all are of course you're gonna watch this video. We've gone over the content, and then tomorrow in class we won't do any lecturing or instruction per se, but we will go right into allowing you to get some practice working on a couple of assessments, as you can see here. As you come in tomorrow, I'll have a bell ringer on the board for you all to do. As you come into class, we'll try to knock that out pretty quickly. All this is going to be is just something for you guys to work on your own, kind of get your mind rolling in this direction, get a little practice before we move into our assignment. Once we finish our bell ringers, I will do a few minutes of just answering any questions you may have. Maybe work a few more practice problems just for you to see. But we're going to jump right into this quadratic worksheet pretty quick. And I'm hoping we can knock this out during class tomorrow. You won't have any homework. And so yeah, tomorrow come in, be ready to work and knock these assignments out. And let's have a good day tomorrow. And I hope that y'all have a good night. Thank you very much.